each of you should have an anticipation guide that has several statements on it that you're going to mark before you watch this video if you think that they're true or false. Feel free to pause the video if there's not enough time. After, we will mark what we've learned in the after watching column and make any corrections to the statements that are false. So, pause this video and write down your answers in the anticipation guide. By the end of this lesson, you will be an expert at understanding there are many ways to represent formulas, and also you'll be able to use tables of data to generate formulas representing relationships involving perimeter, area, and volumes of rectangular prisms. So, let's get started. Let's take a look at a problem that will be using this concept of using tables to create formulas, and let's see what we can figure out about it. So, Xavier has a group of rectangular prisms. Each rectangular prism has a volume of 128 cubic centimeters and a height of 2 centimeters. The table shows the relationship between each prism's length, L, and width, W. So we have our chart, rectangular prisms, width, W, in centimeters, length, L, in centimeters, 1 and 64, 2 and 32, 4 and 16, 8 and 8. The question says, which equation can Xavier use to find the length L in centimeters of a prism that has a width of W centimeters? So we have answer choice A, 128 over 2. Also remember that that means divided by. So we could also say 128 divided by 2 equals L plus W. Then we have B, 2 multiplied by 128 equals L times W, length times width. Answer choice C, we have 128 over 2. Remember, what does that mean? 128 divided by 2 equals L times W, or length times width. And then we have answer choice D, which is 2 plus 128 equals length times width. By the end of this lesson, we should be able to figure this question out. Let's start by reviewing what perimeter is. Perimeter is the distance around a shape. Like for my rectangle here, we're going to measure the units it takes to go around the rectangle. So let's start. 1, 2, 3, 4, 5 on this side. 1, 2, 3, 4 going up. 1, 2, 3, 4, 5 going across. And 1, 2, 3, 4 going down. Alright, so the perimeter, we're going to add up all the distances. So we have 5 down here, plus 4 going up, equals 9, plus 5 across equals 14, plus 4 down equals 18. So the perimeter of this rectangle would be 18. Now, this geoboard has a special tool that can show us the measurement, and let's check to see if it's correct. The perimeter is 18 units. So we got it right. Awesome! So that was the perimeter for that rectangle, but let's see if we can find a general formula for all rectangular perimeters. So we know we had 5 down here, plus 4, plus 5, plus 4. Do we see any similarities in those distances? We have 5 on the bottom and also 5 on the top. 2 5s. We have 4 on this side and also 4 on this side. 2 4s. Let's check another rectangle and see what happens when we create a different one. So I'm going to create a smaller rectangle to see if the same rule holds. So I have 1, 2, 3 up and 1 across, 1, 2, 3 down, and 1 across. So it seems to be that the top and the bottom measurements are the same, and the left and the right measurements are the same. So we know that we can have 2 lengths and also 2 widths. and we have to add up all of those distances to get our perimeter. So our general formula for the perimeter of a rectangle is 2 lengths plus 2 widths. And that will give us our formula for a perimeter. So let's talk a little bit more about perimeter and see if we can use tables to create formulas. Alright guys, I'm in an Excel spreadsheet and we're going to answer this prompt together. Read along with me. Find a formula for a rectangle with a perimeter of 16 units and a length of 6 units. So we have our chart over here with length and width. Length of 7, width of 1, 6, 2, 5, 3, 4, and 4. Now, we're looking for perimeter. Our key word right here is perimeter. So, we know that our equation that we just figured out was perimeter equals 2 times length plus 2 times width. Now, to find a formula, we're going to need to plug in the information that we know. We know that we have a perimeter of 16 units and a length of 6 units. So let's start by filling in those blanks. So let's fill in the P with 16 and the length with 6. So we see that we have 16 equals 12. I got that by multiplying 2 times 6 plus 2W. Now we're going to subtract the 12 from both sides to get the W to where it's by itself. So we have 16 minus 12 equals 2W. Now we still don't have W by itself, which is what we need to find a formula to get the width. So we're going to divide by 2 on both sides. We have 16 minus 12 divided by 2 equals W. Now this is a perfectly fine way to represent a formula for this rectangle. But if we want to check our work to make sure that that's okay, we can go ahead and solve it out. We can subtract 12 from 16 and get 4. Remember, order of operations. Solve the thing inside the parentheses before you do anything else. So 16 minus 12 equals 4. Then we're going to move on to division. So 4 divided by 2 equals 2. And that is our width. Now we can check our answer and look over at our chart to see if a rectangle with a length of 6 has a width of 2. And we did. So it checks out. Awesome. Alright, now that we've done perimeter, we're going to move on to area. So before we move on, we need to talk about what area is. Area is the measure of the surface of a shape. So that'd be just like taking one of these elastics and moving them around one square on the pegboard. So this would be 1 square unit of area. So if we were to count all the squares contained within this rectangle, we would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whew! We would get 20 square units of area. So there's got to be a better way to figure out area, because that is going to take too long, especially for really big rectangles. So let's see if there's an easier way to figure this out. So we know that we have a width of 4 on this rectangle and a length of 5 on this rectangle. So if we look at a smaller type of rectangle, we can see that the area contained by it is 1, 2, and let's see if there's a relation between the width and the length. So if we add these together, that would be just like doing perimeter. But let's see if we can multiply them and see what happens. So if we take this length, 2, 1, 2, times the width, 1, that would equal 2. And that happens to be equal to our area of this shape, 1, 2. So let's see if the same pattern holds for our bigger rectangle. So we know we have a width of 4 and a length of 5. So 4 times 5 equals 20, and that happens to equal our area of the rectangle. And that is how we find areas of all rectangles. So now we need to write out our equation for the area of a rectangle. The area of a rectangle, A, is equal to the length times the width. Okay, now we're back in Excel, but we're talking about area this time. Let's read our problem together. For art class, Rita wants to make an art piece out of square glass tiles. Her teacher will provide her with a certain amount of square inches of tile. She knows she wants to make her rectangular piece 6 inches wide. Shown is a table of the lengths and areas of the rectangle she could make with her glass tiles. Length and area. Length of 1, area of 6. Length of 2, area of 12. Length of 3, area of 18. And length of 4, area of 24. What equation could you use to find the area of the rectangle with length L? Represent the formula in 2 ways. Let's start with our formula that we found on the geoboard, which is A equals length times width. Now let's plug in what we know. We know that she wants her rectangular piece to be 6 inches wide. So let's fill in the width with 6. We have unknowns of area and length. First, we plugged in what we knew. Now, we're going to get length L by itself. We're going to divide A by 6. And we get A over 6, A divided by 6, equals the length. Or, we can do it a different way. We could try to get the variables by themselves from over here. So we could divide A by L to get 6 by itself. If we do that, we have A divided by L equals 6. This would be representing the formula in 2 ways, and they both work. Now, if we want to check our work, we can look over at our table. We can use this equation first. A divided by 6 equals length. So let's take the first area. It has 6, which would be the area right here. And let's divide 6 by 6, and that equals 1, which is our length. So that checks out. Let's try the next one. 12 divided by 6 equals 2, and that is our length. Now let's try this equation and see if it works as well. So we have A divided by L equals 6. So let's find an A. Let's do 18, and let's divide it by L. It's 3. So 18 divided by 3 is 6, and that checks out. Let's try with the next one. 24, our area, divided by length of 4 equals 6. So both of these are valid ways to represent this formula. So now we're going to move on to volume. So now I'm in my 3D geoboard and I'm talking about volume. Now let's talk about what volume is. Volume is a measurement of the space contained within a 3D object. So we need to figure out the measurement of that space. We have this blue rectangle here, which is similar to the rectangle we were working with when we were talking about area, because it has 5 in length and 4 in width. But now that we've added a dimension, we've got to talk about this depth here. It has a depth of 2. Now, like when we were talking about with area, we have to multiply these dimensions. Remember how we multiplied the length and width to find area? Well, now we have volume, which is 3-dimensional, so we have to multiply 3 things to find the volume of this object. So we have length times width. Now we have to multiply times this depth, or sometimes it's going to be the height. So we have 5 times 4 times 2. So that equals 40. The volume of the shape is 40. Now, the general equation for the volume of a rectangular prism is V equals length times width times height. Now, let's put that to work and go to our star problem from the beginning of the lesson and see if we can answer the problem using our new knowledge of the formula of volume. Let's reread the problem again. Xavier has a group of rectangular prisms. Each rectangular prism has a volume of 128 cubic centimeters and a height of 2 centimeters. The table shows the relationship between each prism's length, L, and width, W. And our question is, which equation can Xavier use to find the length, L, in centimeters of a prism that has a width of W centimeters? Now, let's not look at the answer choices and let's think about how we can solve this problem. What's the first step? Well, we have to go back to our equation for volume. Volume equals length times width times height. So, let's write that out, and then let's fill in what we know. We know the volume is 128 cubic centimeters, so let's fill that in for V. And we also know that the height is 2 centimeters, so let's fill that in for the height. So now we need to get length and width by themselves. Well, how do we do that? Well, we can divide this side by 2 if we also divide this side by 2. Once we do that, we have 128 divided by 2 equals length times width. Now let's see if that's an answer choice below. Well, answer choice A is 128 divided by 2 equals length plus W. Well, we know that's not right because volume is all about multiplication of dimensions. So we can automatically cross that out. Let's go to B. 2 times 128 equals length times width. Well, that's saying that the height is multiplied times the volume. And we don't need to do that because that would come up with the wrong measurement. So that can't be it. Now let's go to C. 128 divided by 2 equals length times width. That sounds right, and that looks like what we have. Now let's check it with our chart. Let's choose a width of 2 and a length of 32. Now, 128 divided by 2 is 64. Now, does 64 equal length times width? And the length and the width that we chose were 32 and 2. So let's multiply those together. 32 multiplied by 2 equals 64. So 64 equals 64, and that would be correct. So answer choice C is our answer. Awesome job, guys. You just answered a star question. I think we met our objective of using tables to create formulas for perimeter, area, and volume of rectangular prisms. And we also figured out that there's more than one way to represent a formula. Don't forget to fill in the rest of your anticipation guide and make the corrections to those statements that you think are false.